cause problems. You will also address these issues in the future. Now let's not talk about this knowledge. Because you can't learn it. In the future. You must first learn the division. Then learn this thing. Let's talk about the latter. Updated multicast address. Remember what the multicast address of EIGRP is? It is also 224.0.0.10. The multicast address of RIP is 224.0.0.9. OSPF is special. It has two multicast addresses. One is 224.0.0.5. One is 224.0.0.6. Wait until we finish talking about the state of the interface. Talk about these two multicast addresses. But you need to know. OSPF uses 0.5 and 0.6. The above part is actually some boring theory. Then we will start to look at the part of the message. OSPF has 5 types of packets. Respectively, hello, DD, LSR, LSU, and LSAC. The first is the hello packet. It is a message to keep alive each other. Further down here are some summaries of what we sent. For example, I send you a list. We'll talk about this relationship in a minute. Further down this is a request. Then update. The last one is to confirm. This is the 5 packets of OSPF. There is a saying in OSPF. OSPF has 5 messages and 7 states. This is what everyone must remember. Before we talk about the message. First you have to know where OSPF works. That is. Data encapsulation. Where is this message encapsulated? It is encapsulated on top of the IP layer. Everyone can see. Preceded by an IP header. Behind the IP header is the packet of OSPF protocol. Then in IPv4. I have also said. There is a thing called the protocol number. When the agreement number refers to 89. That means the upper layer is the OSPF protocol. This is a guide for the 3rd floor to the 4th floor. Sometimes you will hear a sentence. OSPF is a routing protocol that works on top of the network layer. That's what I mean. It's above 3 floors. That is. Above the network layer. So what we just saw. What does the updated multicast address mean? Let's go with this picture. When we talked about IP before, we told you. There are some important parameters in the 3 layers. E.G. Source IP and destination IP. The source IP is. Now which address is the source of this message encapsulated? Generally speaking. This is the IP of the outbound interface that sends the message. For OSPF. There are only 2 destination IPs. One is 224.0.0.5. One is 224.0.0.6. It uses these 2 addresses for overall update and learning. That is. This address will be filled. In the destination address of the layer 3 IP. This message is sent to the multicast address. Then other devices in the entire network will listen to this address. Let me give an example. To explain the meaning of monitoring. If a device sends this data to 0.5, another device monitors 0.5. Then it can know the information sent by another device. We sometimes say, send information to other devices. But it's not like sending it directly. Send it here. It goes to listen. That's what it learns. Then it learns. This is called the OSPF updated multicast address. Then I will also emphasize a knowledge to you. For OSPF packets. It refers to the OSPF message transmitted in a broadcast domain. It has a feature. Its TTL is equal to 1. When encapsulating data at 3 layers. There is a time to live in IPv4. after the message is sent out. The number of times that can be forwarded by the 3 layers. If R3 sends a message now, TTL is equal to 1. After receiving R2, its local value will be reduced by 1. Subtracting 1 equals 0. Packets are no longer forwarded. It is equivalent to the end of its life. So actually TTL is equal to 1. This means that it can only be transmitted in one network segment. For the device below, it's impossible to retweet it once. Then the process it sends out is called flapping. The generator of the data is R3. Sent by other devices is exactly the same message as. Then when the data is being sent, it's not called forwarding, called flapping. TTL is the time to live of OSPF over all packets. So it can only be delivered under one broadcast domain. Current stage. You can temporarily understand the broadcast domain as the same network segment. Now for us, each router interface is a broadcast domain. So broadcast messages can be sent so far. And OSPF is also because TTL is equal to 1. It's called hop-by-hop transfer. Hop-by-hop transfer means that devices must transfer one by one. It has no way to cross the traditional. These are some basic encapsulation forms of OSPF we are talking about. Then let's discuss a few parameters. After finishing speaking, let's talk about 5 messages and 7 states. And after speaking, check the configuration according to the parameters. Okay. Let's start with several parameters in OSPF configuration. The first is the process ID. OSPF has a process ID. It is used by this device to identify the OSPF process. Suppose there are a lot of processes running on the device now. Now there are many apps on the device. Actually, every application is an RID. That is, router ID. Now you will see. There are many processes on the device. The data I am generating in the browser now all belong to this process to maintain and calculate. OSPF is the same. You enable OSPF on the device. You can understand it as software on the router. This software is called OSPF. Then this software has to occupy a process in the device. It needs to call some hardware performance inside for calculation. Then there will be a special space range for maintaining internal data. We call it a process. Then under this process, information about all your interactions, configuration you made, the announcement you made, will be owned by the process. It will help you maintain and calculate. That's what I mean. In addition, OSPF processes can open multiple, but at the moment only one, between different processes. You can declare different content. I give a simple example. For example, this is a device. I can open OSPF 100 on this device. Open another OSPF 200. Then they are isolated from each other. There is a network segment on this device. Is 1.1.1.1. Here is a 2.2.2.2. If you declare 2.2.2.2 in process 200. 1.1.1.1 declared in process 100. They do not affect each other. They are completely separate relationships. Suppose there is another device in the future. It establishes a relationship with this interface.